Hello everybody. This should be a very short video on what is called the complex conjugate root theorem, which sounds difficult, but it's really not that bad. Okay, so we have the complex conjugate root theorem, which says, and I'll explain with an example later, but try to follow along, if the complex number a plus bi, so any complex number a plus bi, we can pretend that it's 3 plus 2i, so a is 3, b is 2. So if that complex number is a root to a polynomial equation, any polynomial equation that they give you, then its complex conjugate a minus bi is as well. So that basically what this theorem is saying is that if someone tells you that 3 plus 2i is a root to any polynomial equation, then its complex conjugate, which we define as 3 minus 2i, or a minus bi, is as well. So a complex conjugate basically is the same thing. So if you have a number here, a plus bi, instead of doing plus bi, you're going to do minus bi. Okay, so that's 3 plus 2i is a conjugate, or is a root, then 3 minus 2i is also a root to this function. So basically what this means is that if you know that one complex number is a root, that means that its complex conjugate, it's basically its opposite, is also a root. So in this scenario, so you guys are used to seeing in the quadratic formula this, how it ends up with plus minus something. So you'll have a number here, a plus minus bi. So if you have an imaginary root in here, this plus minus bi, it's always plus or minus because it's the same way as here. So the plus the imaginary part and the minus the imaginary part, both of those are going to make them roots to something. So this means that if someone gives me one complex number, I know that automatically its complex conjugate, or its opposite, is also going to be a root to that function.